Hello students, today we will be going over 7.2, Graphing Solutions to Compound Inequalities. Our objective, I can solve multi-step inequalities and compound inequalities and give solutions as graphs and intervals. We have some vocabulary that we need to go over. There's a picture of set A and set B. Our intersection is the set containing elements, including in both sets right here. So the intersection between set A and B would be 5, because that's what's in common in both. That's intersection with the upside down U. Okay. Union is the set containing all elements from both sets. So it's 3, 4, 5, 6, and 7. Everything together would be the union. Okay. And this is the way you do set notation with the squiggly lines, or the curly brackets is what we call them. Compound inequality is an equation with two or more inequalities joined together with either and or o, or. The solution of an and inequality is the intersection of the inequalities. The solution of an or inequality is the union of the inequalities. Okay, so now we're going to go ahead and start in with the intersection, or the and compound inequality. So here we have number 1. X is greater than or equal to -3 and x is less than 2. So first we're going to graph x is greater than -3, greater than or equal to. Now you can think of this as or equal to here, taking more ink. So this down here is going to take more ink. So when it's like that, you know it's going to be solid. Okay, so this is going to be a solid dot at -3. And you can think of this as going to the right. So we can go ahead and shade to the right. So x is greater than or equal to -3. Okay. The next one is less than or equal to, so that takes less ink, so it's going to be an open dot, and we're going to shade it this direction. See how that makes an arrow go in this direction. And again, this is when the variable's on the left side here. So we're going to have an open dot at 2 and shaded to the left. Now, when we combine the two, it's what they have from both sets. So we won't count anything from 2 on, because that won't be in the set. We won't count anything from -3 to the left, because that is not in both sets. So it's something and something else. Okay, so it goes x is greater than or equal to -3. So it includes that. And x is less than 2. So it's just that one section like that. Okay. Now, it also asks for our interval notation on the right-hand side over there. I'm just going to write it over here. Now, if it includes the number, you have brackets here, and that's if it's solid dot, and that's less than or equal to or greater than or equal to, or it's parentheses, which means you wouldn't include that number. It's less than or greater than. So x is greater than or equal to -3. So we say -3, it's the interval between -3, comma, and 2. So it includes -3, does not include 2. So again, if it's not included, it's parenthesis. If it is included, it's a bracket. And we're done. Okay, so we have those 3. Here's the first one, here's the second one, and here's it combined right there. We'll go on to number 2 now. This is also an and one, where we have -3 is less than or equal to x, which is less than or equal to 0. We're going to graph the first one, which is -3 is less than or equal to x. Now, I like to switch it around, so I'm going to switch it so x is greater than or equal to -3. So it's or equal to, so I'm going to make that a solid dot, and I'm going to, now I can go by the arrow since the x is on the left side right there. Okay, So now I'm going to shade it this direction. Next, right here, it's already on the left, so it says x is less than or equal to 0. So then I do, it's or equal to here, so it's a closed dot, and it's shaded to the left, like that. If you want to shade it darker, that's fine too. Now I combine them and I say what's in common in both. This one's a solid dot, this one's a solid dot, and I include everything in between. And our interval is going to go from -3, and it includes -3, and it goes to 0, and it includes 0 too. And we're done. Okay, you can pause the video and go ahead and do number 3 if you would like. Actually, number 3 might be a good one for me to do as well, because it's a little bit different than these other two. So I'm going to quickly do number 3. X is less than -3, and x is greater than or equal to 1. So x is less than -3 is my first line. Open dot. Then we have x is greater than or equal to 1. There's 1. Oh, greater than or equal to 1. So when we put them together, x is less than -3 and x is greater than or equal to 1. Now what's in common? This one starts at 1, that's one at -3. So there's nothing in common. What do you do then? Okay, there's no solution, so it would just be empty set. So that's also your interval, would be an empty set when there's nothing in common between the two and it's an and inequality. Okay, generalize the shape of the and graphs. And graphs have 2 endpoints and a line between. So again, and graphs have 2 endpoints. So we can go back to this one. Sometimes the endpoints are open, sometimes they're closed with the line in between. So that's all that would be. Okay, let's go on to page 122, number 4. Now we're going to do some OR graphs here. Okay, so for x is less than or equal to -2 or x is greater than 2. So we're going to start with the first graph. X is less than or equal to -2. And there's my first graph. Second graph, x is greater than 2. It's got to be an open dot. Less ink here, less ink here. Okay, they're not actually drawn so you can compare the two, but with OR you just include both graphs. So x is less than -2 or equal to -2, or x is greater than 2. So again, this one, it's not including it. This one does include it. Okay, so now when we do our interval, this we go to the lowest number first, so we go to -infinity, comma, and it goes up to -2. Now, our negative or positive infinity is always parenthesis because you can never quite reach it. -2 is included, so it's a bracket. Okay. Then I'm going to go ahead and put a union, because that means we're going to say the answer is both of them. Starts at 2, doesn't include the 2, and then it goes positive infinity. And that one will be parentheses right there. Okay. All right. I think you can get the rest of these, students. You rock.